We have all the assets we need ready to be put together into a game. In this video, we're ready to put it all together with gameplay, scoring, and bonus points. There's a lot to do, so let's just get started. Make sure you're starting in the C4 game stage map. We're going to start by creating a way to keep track of the value of each point, the player's score, and which quadrant contains the bonus. The blueprint that will handle the player scores and the state of the current game is the player state and game state. But since we are developing a one-player local game, we'll handle all this logic in the game mode to keep everything together. Before we start, let's add a couple variables to our struct VR player that we created a few courses ago. Open the struct VR player settings asset in the structure folder. Add an integer named dart game points to win, and set the default to 200. Add an integer named standard point value and set the default to 20. Add another integer named bonus point value, setting this default to 50. Lastly, add an integer named updated player score. Save and close. Open game mode darts and create a custom event named check game status and attach it to a branch. This event will be called to check if the game is over or can keep going. It will figure it is over when the player has surpassed the amount of points needed to win. Drag in a reference of the previously created variable game instance darts. From there, get the struct VR player settings and create a break struct VR player settings. Hide all pins except dart game points to win and updated player score. From points to win, create a less than or equal to node. Compare this value to the player score. And we're going to plug that right into the branch. Create a new variable of type bool named game over. And I'm going to place mine in a category called game state. And compile. From true, set game over to true. Next, create a custom event named player has scored with one bool input named bonus hit. We'll call this every time the player has scored to distribute the proper amount of points and then check the status of the game. We need to make sure that this is only called if the game is still going. Create a branch and attach game over to the condition. If game over is true, don't do anything. But if it's false, we can continue. Grab another reference to our game instance struct and break it. Show the standard points value, bonus points value, and updated player score. Drag from the struct VR player settings and create a set members in struct VR player settings node. Show only the updated player score. Working backwards from updated player score, add a plus. Plug in the updated player score from the break struct node to the plus. From the other input on the plus, drag from it and create a select int node. Oh, I just noticed I misspelled hit. Too many eyes. Plug the bonus hit bool into pick A, which is in the select int node. If we were successful in hitting the bonus quadrant, choose the A value, and if not, choose B. So we're going to plug the bonus point value into A and standard point value into B. For now, let's just print to the screen the updated game data. Create a print string node, and from the in string, search for an append node. We will need a few strings to append together for this. In A, type player scored space. Make sure to include a space. In B, plug in the return value of the select int. This will automatically convert our integer to a string for us. Add a pin, and then in C, type space points. Score is now colon space. Be sure you have those spaces in, otherwise the spaces won't be there and the numbers will be right next to the word. We need to add a pin, and then in D, we're going to add the updated player score. If we plug it into the result of the sum, we will get the score plus the result of the sum as the score has been updated before we call the print string node. Always be careful when lining up your logic. So I'm actually going to plug it directly into the updated player score. Now, just to make things easier, I'm going to make this a nice bright orange and make this last 10 seconds so it stays on screen a bit longer. And I'll compile this. Call check game status after the print string. Open BP dartboard and create a new integer variable named bonus quadrant. I'm going to change this to integer, and I'm going to place this into a quadrant category and compile. Plug in our new bonus quadrant variable into the equals 2 node. Plug that into the comparison after determine quadrant of hit. Let's delete the branch and instead get a reference to the game mode and cast to game mode darts. Call the event player has scored and plug it into the results of bonus hit. Now we need to create a quick function to randomly pick a new quadrant. Create another custom event named setNewBonus. After we call player has scored from the cast to game mode function, create a branch. Plug in the result of the bonus quadrant check, and on true, call our new setNewBonus event. Create a new integer variable named possible quadrants. We can quickly change a variable to an array by right-clicking on the variable type. Alt-drag possible quadrants after setNewBonus and connect it. Right-click in the event graph and search for make array. We're going to create an array of integers with 4 items each time we call this event. We'll then remove the current item that is the bonus quadrant so it can never repeat, and then we're going to set a random one as the new bonus quadrant. Click Add Pin on the Make Array node until we have a total of 4. Insert each number 1 to 4 in its own space. Because we are building this with specific integers or items, the order does not matter. Just be sure that they are all there and all different. Drag from possible quadrants and create a remove item node. Plug in our variable bonus quadrant to the item. Next, for good measure, shuffle the array. Alt-drag our bonus quadrant variable into the graph. From possible quadrants, create a get copy node, and from the index to get, create a random integer in range node, set it to 0 and 2. Plug in the result to bonus quadrant. Again, we'll create a new print string node to the end to tell us what quadrant the bonus is. And I'm also going to add another append so I know where this print string is coming from. I'm going to type bonus is now in, and I'm going to plug bonus quadrant into B. Call setNewBonus at the end of begin play to make sure we have a starting bonus quadrant. If you press compile, you may get a warning on the possible quadrants array. What Unreal Engine is telling you is it can't parse the default value of 0. To get rid of this warning, just simply press compile again. So, with all of this set up, let's test and play some darts. So I'm going to grab my dart and I'm going to throw it. Say, let's see, player scored 20 points. Score is now 20. Score is now 40. Oops, missed. I can get it. I can get it. There we go. Hey, there we go. Now I hit the bonus. Now my score is 90, and the bonus is now quadrant 3. Whoops. And there we go. I hit the bonus again. Bonus is now quadrant 4. My points are 140. Hit it again. So you can see that it is not repeating, and we have a dart game that we can play. In this course, we learned how to handle our hands while in VR and the various methods Unreal Engine provides us to create an immersive hand presence. We created logic for picking up various objects, created new animation assets that we are blending between based on logic in blueprints. Also, using only engine assets, we created a dart game with a mathematical twist for a player to prove their skill. But this is just the start. The real learning will happen when you take these insights into your own projects. In the next course, you're going to learn about building and implementing UI in your projects by using Unreal Motion graphics. See you there.